to another A-Level Computer Science video with me, Mr Goff, for MrGoff.com. This video will focus on range and precision. The range and precision of a fixed point binary number is determined by the position of the decimal place. When we have more bits for the whole number part and less for the fractional part, we have a greater range of numbers we can represent, but a lower precision. And that's also true in reverse. That is, if we have a smaller number for the whole number part and more for the fractional part, then we're able to represent a smaller range but with higher precision. Let's take a look at some examples. With 3 bits for the whole number part and 5 bits for the part, the largest number we can represent is 3.96875 and the smallest number is -4, a range of 7.96875. How precise can we be? To the nearest 0.03125. However, if we use 5 bits for the whole number part and 3 bits for the decimal part, now the biggest number that we can make is 15.875 and the smallest is -16, a range of 31.875, much bigger than before. However, the precision is now down to the nearest 0.125, which is not as accurate. For floating point numbers, the range is affected by the number of bits given to the exponent and the precision by the number of bits given to the mantissa. If we look at an example with 5 bits for the mantissa and 3 for the exponent, the smallest number we can make is -8 and the largest 7.5. But if we change that so that we have 3 bits for the mantissa and 5 for the exponent, now our smallest number is -32,768 and our biggest number is 24,576. It's also important to note that we're able to represent very, very small numbers using negative exponents. So the smallest number that we could represent here would be 0.25 times 2 to the -16, which would represent this very, very tiny decimal here. When we compare fixed point and floating point numbers, we can see that floating point numbers can represent a wider range of numbers with the same number of bits. Floating point numbers can make both larger and very small values that cannot easily be made with fixed point. However, fixed point numbers are simpler to represent and so faster to process. That brings us to the end of this video looking at range and precision. Join me in the next video when I'll be looking at the normalization of floating point numbers. Use the resources at MrGoff.com to help you revise computer science. And until next time, it's bye for now.